So we're back with hour 3. So what I want to do is spend some time kind of doing a bit of a review on JavaScript. These slides are all on Blackboard. I'm not going to go through all of them. I just want to hit on the ones that I think are relevant. But all of these notes and samples are on Blackboard. It's in the week 2 folder in weekly learning. It's in lesson 2. Which would be right here, this introduction to JavaScript. I've also given you a link here if you want a bit more practice. There's a couple of free tutorials here on Code School. That may not be a bad idea, a couple of them. So these are free. So there's a few videos. And this is just basically basic JavaScript. That's not a bad review. So totally optional, but if you want more practice, here's an easy place to go rather than you having to find it. I've given you that as a resource. Okay. So we're just going to talk about JavaScript in general. We're not going to talk about JavaScript in the browser at all. We're not talking about the DOM. We're not talking about any of those objects that you're used to using. Okay. But a few things about the language I want to point out. Okay. So a couple things to remember. One is that white space gets ignored in your JavaScript. So much like in PHP, we can put in extra spaces, extra lines, indenting. That gets ignored. Okay. Commands are terminated with a semicolon. We'll need to remember that. JavaScript is also case sensitive, right? So if we create two variables, the same word, we capitalize a letter in one instance, we don't capitalize in another, JavaScript's going to consider those two separate things. Okay. So for example, right, if I was writing JavaScript, I'll just take this out, in JavaScript, those are two separate values because of that capital F. So that's something to remember. So we'll want to make sure when we're using multiple words in the name of a term, just like we did in PHP, we'll want to make sure that we're consistent with how we name things. Now in PHP, I tended to prefer this kind of notation. I used underscores in all lowercase, which you can do. However, when we're working with Node applications, the Node standard is actually to use camel case. So in Node applications, we're going to see code samples that look like this instead. So I'm going to use camel case so that what you see will be consistent with, if you have a copy of the textbook or you look at Node documentation, they're probably going to use this version on line 7. So that's what I'll use in class. Okay. Our basic math operators, plus, minus, star, divide. It's been a while, so we should probably refresh. What's the difference between equals and two equal signs? Vadim?
One is Boolean and one is equal. So one is when you're assigning value and the other is comparison.
Right, so when we're setting the value of what we're giving something a value, we use one equal sign. Right? X equals 2. The double equals is when we're comparing two values together. So usually that's going to be inside of an if statement. If this value equals that value. Maybe password equals confirm value. We're checking whether they're the same. So it's no different than in PHP. Okay? We have the brackets and curly braces just like we did in PHP. So around a block of code or inside of an if condition, all those things are going to be inside curly braces. Okay? So identifiers, these are the things we name. So variables, functions, objects, properties, and methods. And they're case sensitive. And I will use camel case for these, for naming these objects. And all of them are case sensitive. Now variables, in PHP, variables were created with a $sign, right? If this was PHP, it would look like this. What if I wanted to use a variable in JavaScript? We don't use $signs in our variable names. How do we indicate something is a variable in JavaScript? So we use the var keyword. So in my JavaScript, if I want a first name variable, I'm just going to prefix it with the word var. That indicates it's a variable, which is actually more user-friendly than the $sign, really. Okay. So these are the only characters we can use in the identifiers. Letters, numbers, underscore, and dollar sign. Those are the only characters allowed. So for example, you're not allowed in JavaScript a variable like this. JavaScript isn't going to allow that. Now I put up a little tool, actually. This is a good place for us to play around with it. This is a great site for testing your JavaScript code. It says Online JS Console. I may as well play here. So this is a little JavaScript window where we can type JavaScript on the left and we'll get output on the right. So they've given us a sample here. I'll just clear the results. So if I click on, it's hard to see, on mine JavaScript and console are highlighted. If you want to test out HTML, you can do it. CSS. So I just have clicked on JavaScript and console. So if I delete this stuff, if I type var first dash name, this actually debugs my JavaScript. So the first thing it says is, dude, no semicolon, right? So I put that in. That error goes away. But it doesn't like this because of the dash. If I try and run it, I get an error. If I change that to camel case, and clear, goes away. Okay, so any JavaScript we want to test as we're working, if we want to test a little snippet of code, we can just go to JS bin and run it here, which is great. Rather than having to save our file and run it, let it crash in the browser, we can actually test things out here. So I'm actually going to use this quite a bit because it does live debugging. Okay, so that link is here for you, this Online JS Console. I'll probably use it a lot through the semester. Really useful tool. Okay. So the identifiers, as we said, they're case sensitive. They can't be reserved words. So what would be an example of a reserve? What would be something that I couldn't use here as a variable? What's a reserved word? Okay, so if I call a variable, try and call it function, doesn't like this, right? I can't create a variable and call that variable function because function is a keyword, a JavaScript keyword. Or I couldn't use a word like if. Again, any word that's part of the language we can't use as our own identifier. So here's a list. So here are some valid identifiers, and this would be, everybody knows what camel case is. I don't think I have to spend too much time on that. So generally, give meaningful names and either use camel case or underscores. Okay. As I said, I'm going to use camel case just because that's common in Node. Here's a list of all the reserved words in JavaScript. So you can't use any of these for your own identifiers. If you tried to create a variable with any one of these names, you're going to get an error. And again, we can see that. So for example, public. I shouldn't be able to do that. So there are reserved words. Okay. Now you would be familiar with this from your client-side class as well as from what we did in .NET. JavaScript allows us to have objects, and objects have properties and methods. We talked about this on, I think, day 1 or I think it was day 2 of our ASP.NET class, and we're used to using properties and methods, right? We had a text box object in ASP.NET. Well, it had properties like .text or .enabled or .visible, right? Buttons had methods like .click, for example. So same in JavaScript. So, you guys have done this in the DOM, right? You've done it on client side. We've got a window object. So what would be some of the properties or methods of the window object in client-side JavaScript? We have a window object in our browser. What might we do with that window object? Okay, so it had a load method that we could refer to in JavaScript in client-side as window.load. What other things could we access with, say, the window or the document object? What method of the document object did you access probably all the time in your client-side JavaScript to refer to a particular element in the document? Right, we would call document dot, we'd call the get element by ID method, so we could identify and reference a particular element on the page. So our server-side JavaScript is going to be the same. So it's always the name of our object and then a dot. So sometimes these are built-in objects that come with JavaScript. Sometimes these are our own objects. So we might, for example, if we were creating a shopping cart, we might have a customer object. And we would define what the properties of that customer are. You know, first name, last name, credit card number. And we could create methods on that customer object. Checkout, login, etc. So we're always going to use this dot notation, the name of our object, then the name of the property or method we want. We have some basic data types. Basically, we've got numbers, so two kinds of numbers, integers and decimals. I think by now everybody knows what those are. Okay. There's a Boolean and string data, as well as there's a date data type. So those are the basic data types we're going to be working with in our application. Okay. All of the normal math operators we've used in every other language, in C#, in PHP, they all apply. So we can use brackets for doing order of operations and the regular math and operate comparisons like greater than, equals. All of those things apply in JavaScript just like in the other C-based languages we've worked with. So a quick table here. All of these are pretty self-explanatory. The only one we maybe haven't worked with a while is plus, plus, and minus, minus. Okay, so our example is here. So if we want to add one, we can say, you know, our variable +1, or we can say our variable ++. Does the same thing, adds 1, or minus, minus will subtract 1. Okay, so our order of operations are here. One of the things we should talk about is the plus operator. So if we do this, well, let's try this out. I'll try this in. So if we do 3 plus 4, and actually want to display this, I guess I'll wrap this in an output statement. Here's kind of our equivalent of an echo statement. We'll log to the console. So here it gives us 7. So JavaScript infers that these are numbers. Okay. What happens if we put these in quotes? And this could be single or double. If we run this, what are we going to get? Right? So JavaScript it infers the type. Okay? So we don't use the stupid, goofy dot operator for concatenation like we do in PHP, thank God, which I hate. We use plus for concatenating as well as for adding. Okay? So if we want to treat these as math, we're going to have to convert them to numbers first using the parseInt function. I think if we tried that, so we have this function for converting. We can try it this way. This should give us 7. So this parseInt converts those text values to numeric values and allows us to add them. So if one value is a number and one is a string, JavaScript will convert the number to a string. So let's try that one. So if I take this one out, actually, whoops, we'll leave that one. We'll clear my console. So let's say I put quotes around the 4 but not around the 3. This gets converted as long as one of the values is a string, it will assume the others are strings. Okay, so these are just a few little things we need to keep in mind in terms of how JavaScript treats those data types. So string's going to be the default. If we have a string and we concatenate, it treats everything like a string. So a few examples. So we can declare variables, each variable on a new line, or we can declare them all on one line with commas. Both are correct. Whatever syntax you like is fine. And we've got operators like plus equals. In PHP we use dot equals. So what does plus equals mean if we look at this example? We set our variable to 74.95 and then we said subtotal plus equals.
So it's add to the previous amount?
Right, so plus equals means keep the existing value and now add on to it. So this will give us 74.95. If we do plus equals 20, we're going to get 94.95. So keep the original value and add on to it. So this is good if we're doing some kind of running total, like in a loop. Maybe we're going through someone's shopping cart and totaling up how much that cart's worth in total. Here are some common sequences for escaping in JavaScript. So again, these slides are just helpful for you to use as a reference later on. Hey, I need a new line or I need a tab. How do I do it in JavaScript? So /n is a new line, /t is a horizontal tab. That's the common one. Or we want to escape quotes, right? Because we have a string with a quote in the middle. We can just escape them with a backslash. So here are our logical operators, the same operators we used in PHP. So an exclamation mark is not, 2 ampersands is and the double pipe character would be an or. So I think we're familiar with these. I know you just haven't worked with them for a little while. Our if structure, you guys are familiar with, again, the same structure that we used in PHP, same structure we use in C#. We've got if, our condition goes in round brackets, and then our statement of what should happen if that condition is true goes in curly brackets. And we can have else if and else. So this is exactly the same as what you've already done. Okay. We also have while. So while a condition is true, do something. Or we can use this syntax, do something while a condition is in effect. We'll basically get the same result, really just 2 different ways of writing the same code. We also have for loops, same like we did in PHP. So we start at a counter, we start at a number, we say when we're going to stop and how many times by what we want to increment, which is usually 1. We'll try this in a minute. So for example, if we want to work with the date object, we can create a new date, call it today, and because date is a built-in JavaScript object, we've got all the access to all these methods of the date object, like getMonth or toString. We've got built-in string functions like converting to uppercase, converting to lowercase, finding out the length of a string, extracting part of the string, all these things that we've done in some other languages. All this stuff, JavaScript has it too. Here's the confusing part. Anonymous functions. This is new. I'll show you the file we wrote last week. Right? Here was our blocking. So this looks fairly normal, right? Node comes with these methods called read file sync. So here's our object, our file system object. It contains a read file sync method with 2 parameters. What file are we reading and what's the encoding? This looks fairly normal. However, when we did our non-blocking syntax, we got this funky syntax. We created a variable and we created read file where we said what file we wanted to read. We said what encoding. So far the first part is all the same. But then our last parameter, we passed in a function. And usually when we have a function, usually we're giving that function a name, right? Let's say we make a function to calculate taxes. It would look something like this. I'll go ahead and do one. We'll do an example. So I'll clear this out. So here's my named function example. Okay? So this is what we're used to. We'll create a function called calctax. And we'll create a variable of subtotal. So we'll calculate the HST. So the way we do this is we will return the value of subtotal times 0.13, right? We're adding 13%. That'll tell us how much tax. So this is kind of our traditional, okay, it says to use 0. So this is what's called a named function. We've created a function and we've given it a name. So now let's say we want to calculate the tax on something. So we can create a variable called tax. And we'll say tax equals. So how would we calculate tax on $100? How would we use our function to get that value? Yeah, so we'll put in the name of our function, and we'll pass in 100. Right? So we're creating the function here, and then we're calling it here, and we're giving it a value of 100. And now if we want to display it, we can just log out the tax. Right? So we're doing this in 2 steps. Create a function that just kind of lives here waiting to get called. And then down below we'll invoke it, pass it 100, and then we'll display the result. So when it runs, so we're creating an empty variable. We're then calling our function, passing in 100. Our function sends back a value of 13, which is now in our variable, and then we're outputting it to the screen. So this is kind of the traditional model of using named functions. This is sort of what we're used to. And you may have done something similar to this in one of your client-side classes. So we can do this. The thing with using this syntax is, we talked last week all about asynchronous code with Node, right? With asynchronous code, this code is blocking, right? So once we call this function, when we use named functions, this function, if you remember the guy's terminology from the video on Code School, this function blocks the world. When we write the code this way, once we call calc tax, nothing else happens in our application till all this processing is done. And this might be a very involved function with a lot of processing. Maybe it has to connect to the database, read a file, perform a lot of complicated logic. Our code will work, but nothing else will happen because this is the blocking method of writing this code. So here would be, I'll just open up a new JS bin window. We're going to try the same code, but without using a named function. So we're going to use a different method for this. So now we'll try what's called an anonymous function. So here's what this is going to look like. We'll create a variable called tax. We're basically doing 2 things together. So here we created the function first, then we created the variable, then we called our function to put a value into our variable. With the anonymous function, we're doing these things all at once. So what we're calling is a function, but our function has no name. All it takes is a subtotal parameter. So now in here we will simply return so these 3 lines are equivalent to those 4 lines. We're doing it all at once. So this is now up here, and notice here our function is named. We've called it calc tax. Our function here has no name. we're just going to populate our variable with the result of this function. Okay? The code is actually doing the exact same thing. This is kind of a shorthand. But this also can run asynchronously. So now, if we want to calculate the tax, we can log out our tax variable and pass in 100. We get the same result. So the code's actually doing the same thing, but this version is going to be blocking. And this version, if this is long and we have other things happening, this can run asynchronously with this syntax, with using anonymous functions. Okay? It takes a little while to get used to this. I find this is very readable. It's really clear what we're doing. We're creating a function over here, a piece of code that we can call. And then down below, we're going to call it and get the result. Here, it's all happening at one time. We're creating the function and basically calling it and filling the variable with it all in one step. But this is what allows our asynchronous or our non-blocking code to run by using this format. So most of the functions we write in here, they're going to be anonymous using this method. And if we look back at our non-blocking sample from last week, you'll notice our function is anonymous. It has no name. Okay. So I realize this is new. But by doing this, it allows this function to be called, to start running, and then the rest of our code to run, and this function to get called back when it finishes. And that's really the big advantage of using Node, is we get that speed boost from our asynchronous or non-blocking code. Okay? So this is the first time we've tried it, but everything we do, all of our functions are going to use this anonymous format. Okay? Questions? I'll save this example onto Blackboard. I'll put these into one file so you'll have this as a reference of the difference. So, and it's right, it's also described here. So we create a variable and we set it equal to our function and whatever parameters that function needs to run. Okay. So there are a few other examples here. In fact, this one is actually an anonymous function in client-side scripting using the DOM, right? So we just create a variable and we call get element by ID and we set that element equal to our variable. Or here's an anonymous function with 2 parameters. So there's no name after the word function. Okay. So here would be our named function. We've put in the word function and then we give it a name. So this is the synchronous or blocking way. This is what we might be used to doing. But we won't really use this in Node. There's a bit of a note here on variables. And arrays we're going to use a lot. So we're going to do a simple example together using JavaScript array. We've got 15 minutes. So we're going to do this example together. Okay, so arrays have a few properties. A length property, which will tell us how many items are in that array. That's the main one that we need. So if we've got an array with 4 elements, the length will tell us how many items are in there. So I've got a quick example. This is a for loop showing how we would loop through an array, but we'll do one together. Okay. So if you go to Blackboard, there's this practice with JS arrays. So here's what we're going to do. I've given you an array here, and not only is this an array, but this is a nested array. So we have one array, and then inside each element is its own array. So we have a type of food, and then we have the ingredients for that food. Okay. So what we want to do is use JavaScript to display this array this way. So we're going to use a JavaScript loop to go through. We'll need one loop to get the main food elements, food 1, 2, and 3, and then we'll need a second array inside to do each ingredient. So we'll do this together and we'll run it in the JS bin to try it out. So I'll open up one more JS bin window. And I'll turn off my HTML and my output. I'll turn on my JavaScript and my console. So on Blackboard, let's grab this little piece of code here. Let's grab my array that sets up the foods and the ingredients. So just highlight that, copy it.
Where are you on Blackboard?
Weekly learning, week 2, lesson 2. It's this practice with JavaScript arrays. So highlight this little section at the bottom and copy it. Paste it in here. Can make this a little bit bigger. So we have basically a nested array. So the first element in each array is the name of the food, and then all of the other elements are the ingredients in that food. So we want to use JavaScript to loop through to produce this list in this format. This is what we want to see. Now, if you want a challenge, you can go ahead and try that on your own, but I'll walk through doing it. Okay. So we're going to loop through the outer array and show each food. So how would we do this? What kind of loop would we use to display sushi, tacos, and pizza? Let's do that first. First, we just want it to display these 3 values.
For loop.
So we can use a for. So we know we're going to need this syntax. So where are we going to start? What number should our loop start at? We want to start at 0, the first element in the array. So typically for a counter, we can use a variable called counter, or shorthand is common to just use a variable called I for integer. So we'll start with I being 0. That's where we want to start our loop. We put in a semicolon. When do we want to end the loop? Yep. So we can say, so long as I is less than 3, or we could say I equals 2, either one. And how do we want to increment our counter? We'll use I++, so go add 1 to the counter each time. So start at 0, then go to 1, then we're on 1, go to 2, when we're on 2, go to 3, and we'll stop. So we want to display sushi, then tacos, then pizza. So what command will we use to output? We'll use console.log. So how do we access these 3 values? And I'll put in a semicolon at the end. How do we access those 3 values first? We'll leave the ingredients after. Let's get it working first to display these 3 values. Okay, so foods, which is the name of our array. Well, let's try it this way. Let's see what happens if I just run it like this. I get everything. So it's giving me the first one, the entire array each time. We don't want the entire array, we just want the word sushi. So how would I refer to the first subarray, but then the first value in there? Because when we say food 0, it gives us all 4 of these values. We just want this value. Everything we have is correct, we need to add something to it. Well, eventually, for now, so we've used 0. So what we want is this. So for each item in the array, show the first value. Let's try this. Right? So the first time around, I is 0. So 0, 0 is sushi. Then we add 1 to I. Now the value of I is 1, which takes us to the second element in the main array, first column, first value. So now 1 comma 0 is tacos. Now I becomes 2, then it prints pizza. So that's printing out the first 3 values. That's good. So we'll just say print the food name. So after we print the name of the food, remember we want the output to look like this. So we'll print sushi. Before we print tacos, we need to print all the ingredients in sushi. And we also want to tab it. We want to indent it. So now, Mallory, now we'll come to your suggestion. So how now, after we print sushi, how do we get it to loop through and print out these items, each one on a new line? So in this case, sushi's got 3 ingredients, pizza's got 3 ingredients, tacos has 4. So we don't know how many ingredients there will be. So how can we get it to print all the ingredients regardless of how many there are?
Do another for loop, except instead of having the I set to a small I is greater than 3, you instead set it to I equals the foods iteration dot length.
Okay, and we probably want to use a different variable because I is counting the rows. We need another variable for counting the individual items inside. So typically, if we need another one, we'll use J. So what number do we start at? What should be the first thing I print out after sushi? Looking at the values. What should be the next value that gets printed? Yeah, we want to print rice as the first ingredient. What position is rice at? 0, 1, 2, or 3? It's at position 1, right? Because sushi is position 0. Rice is the second item, so we want to start in this case at position 1. We want to ignore the first item in each row because the first item is the name of our food. We've already printed that. So now we want to start at position 1 and we want to go to what? Because we might have 3 ingredients, we may have 4. How do we know? So J is less than, it's actually foods I dot length. So for the current food, we want to get all of the elements. And then we'll increase. So in the first case for sushi, foods.length will be 4, right? There's 4 items. So we want to stop at after the third, this item. For tacos, the length will be 5. So the length is going to be dynamic depending on which food we're looking at. And now we want to console.log. The first thing we want to tab it, we want to indent it. So we'll put in a /t. That's an escaped T. And then we want foods I and J. So both of those values are dynamic now. So for the current food, display the current value. Let's clear it. So this is what we want. It displays the food. Then it displays column 1 with a tab. Tab again, column 2, tab again, column 3. Now this loop is finished, and then we go to our next food, tacos, tortilla, meat, and cheese. So this is the kind of JavaScript we will typically be using. These things, these anonymous functions, we will be working with arrays and collections a lot. And as we're building our node apps, we're going to use console.log constantly so we can be checking what's going on. and we'll use this JS bin. I'll put this solution up on Blackboard. In fact, it's already here. So I want to show you your lab. Okay, you have until tomorrow night. So the lab is to give you some more practice with JavaScript as a refresher. Where is it? Whoops. Sorry, I think I went into the wrong place. Keep clicking the wrong one. So for your lab, I think I've given you the link. Here's the link. I'll show you what it looks like. So basically, you just do the whole lab on the Code Academy site. You can work there because it helps debug your code as you do it. So they've got instructions here. So you basically type your code online, and as you go, you click Save and Submit, and it will check your code for you. And if you've made errors, it'll give you hints. So there's about, I don't know, 9 or 10 steps. Let's see how many steps to go through. Yeah, so there's 9 steps, and you just follow the instructions. So you start. Oops, what did I click? So here, there's instructions are on the left. So for example, it'll say declare a variable called user choice. So I'll create, and that's in camel case. Right? And then it tells me step 2. And they've got hints here as well. When I think I'm done, I'll click submit, and it'll say, oh, you know, you didn't do this. You've created the variable, but you didn't give the user a prompt. Okay, so when you're done, you'll have one JavaScript file, and when you run that file, it'll play rock, paper, scissors. So what you need to do is go through to complete the tutorial. When you're done, you'll have in this window, you'll have one completed JavaScript file. So you can run it here. You can also copy and paste it into JS bin and try it out if you like. Okay. So then what I want you to do is create a Lab 2 repository. Commit and push your JavaScript file to Lab 2. So then what I'll do to mark it, I'll click on your repository link, I'll copy your code out of Lab 2, I'll paste it into JS bin, and I'll try and play your rock, paper, scissors game and see if I can play it. Okay? So it's going to give you practice with variables, it's going to give you practice with if statements and conditions, as well as displaying and making decisions. Okay, so it's a good little practice, and everybody knows what the rules are of rock, paper, scissors, which means you understand what the you know already what the output's supposed to be when you're done, right? Because everybody knows what the rules are of the game. So basically, what will happen is you'll prompt the user to type in rock, paper, scissors, and there's a random function in JavaScript, and the tutorial shows you how to use it. So the computer will randomly choose rock, paper, scissors. You prompt the user to type in rock, paper, scissors, and then your application will decide who wins. Did you win? Did you lose? Or was it a draw? Okay, so you have until tomorrow night to do it. And this is pretty good because it will give you hints as you go, and it'll help tell you what you're doing wrong. Okay, so just submit the completed code as a single JavaScript file in a new GitHub repo. So you'll have 2 repos by tomorrow night. Lab 1, which is just using Git.
Yeah.
Probably some of you have done it already. Lab 2, which is your rock, paper, scissors game, okay? So you have until tomorrow night. That's for total 5% of your mark.
So like, you put the links out to our GitHub on Blackboard.
Yeah, so all you need to do is for each one, submit the repository link on Blackboard. You don't have to upload the code to Blackboard, just commit and push the code to GitHub. Okay. So then next week, what we will get into, and what might not be a bad idea to have a quick look at before next week's class, next week we'll start with Node. Okay. There's a good link I've put in the Lesson 3 folder. It's at the bottom here. It says, why the hell would I use Node.js? This is a good little article describing what types of applications Node is a good fit for and what type of applications Node makes no sense for. So it provides some context with looking at, he's got some good diagrams and he explains where Node is a good fit. So you may want to have a read through this as an introduction. It's a really good background for what we'll be doing next week. And we'll actually start with Node next week. All right, so that's it for today. I'll put my little array code up for you guys on Blackboard. I think it's already there. I just have to turn it on so you can see it.